just when the universe and time would end, Saul and his team began to hunt for extremely rare objects known as supernovae, the aftermath of exploded stars.
There are two things you need to know about a given supernova once you've discovered one. First, its peak brightness. That tells you how far away it is, and hence how far back in time the explosion occurred. The other thing is you want to look at its color through its spectrum. And the more it's been shifted to the red, it's called redshift, the more the universe has stretched since the time of that explosion.
Painstakingly, Saul and his team began to discover one supernova after another.
After several years of the supernova hunting, we had built up a sample of some 42 supernova, and we were finally ready to go back to ask that question that we began the project with: what is the fate of the universe?
But the answer they came up with came as something of a shock.
When we finally graphed the results, we found a very surprising result. Apparently, the universe is not slowing down. It was actually speeding up, and that was the big surprise.
In other words, the universe wasn't headed for a big crunch at all. So what will its fate be? Saul's discovery has helped scientists to map out how time and the universe will evolve. An incredible space epic separated into 5 long ages. The first of these was the primordial age, starting with the Big Bang and the birth of time. Lasting only 350,000 years, that's long gone. We're now 13.7 billion years into the second age, and it's only just beginning. We live in something called the Stelliferous Era, an epoch that has brought us not just the stars and the planets, but also every speck of matter in the universe. One day, 100 million years from now, a mere finger click in the life of the universe, this golden age will come to an end. In its place will come the degenerate age, when the last stars burn out and die, when the planets fall from their orbits, and in the darkness of space, matter begins to decay. After a truly unimaginable length of time, only black holes remain. A fourth age that far exceeds all the time that has ever gone before. But even black holes don't last forever. Little by little, their thermal energy will leak away, until ultimately they too disappear. So what does this mean for the future of time? Does the death of our universe mean that time is destined to run out? Or is time really eternal, without end? Even as the last black hole evaporates, a fifth and final age is beginning. The age of the photon, in which time finally fragments into total disorder. When all that remains of our cosmos are invisible, indestructible, low-energy, light particles. For Saul Perlmutter, this cold chaos represents the ultimate destiny for time.
This particular picture of the future of the universe, and we don't know if this will be the final answer, would have time lasting forever. There will be no end to the universe in this particular scenario.